So I'll give you the answer for these questions. Okay, second one, the answer should come pi z over y comma 2 y squared minus z minus x cubed divided by x, which is equal to 0. Sorry, this is not a pi, this is a g. Okay, this will be our pi, this will be our chi. So I have given you the answer. You just do all the steps. So you have to use the exact equations and this integral factor, those kind of knowledge, okay, to solve our this format, mdx plus ndy is equal to 0. Okay, try yourself. Okay, I hope that 2 questions enough. Okay, 1, 2. This is 2, okay. Okay, let's go back to our type number 3. So this is also having the auxiliary equation type. So this kind of equation we called Lagrangian multipliers method also. Okay, it's also called as a Lagrangian multipliers method. Okay, okay. Just write down this description also. So type 3, write down, let P Q R1, let's say P1 Q1 R1 be functions of x, y, and z. Wait, give me a second. Okay, so we have function z. Okay, then by a well-known principle of algebra, each fraction of dy dx over p dy over q, still we are using our Lagrangian auxiliary equation, equal to, okay, we're going to use this to get a Lagrange multipliers. Okay, multiplier means we multiply these numerator and denominator and add up. Okay, something like this. Let's say p1 dx plus q1 dy plus r1 dz, okay, divided by p1p, okay, q1q plus r1r, okay. This is our second equation, equals to this one. So let another P1, Q1, R1 be a function of X and XYZ again. Okay, we are taking some multipliers. Okay, then by a well-known principle of algebra, each fraction of, we can see what is that algebra. Okay, each fraction of dx or p, dy or q, dz or r can be equal to. So what is happened? See, I have multiplied this up and down, like numerator and up, denominator by capital P1 and numerator and denominator this by capital Q1 and this one by R1. Then I add all the numerator as well as divided by the all denominator of multiply P1, Q1, R1. Okay. So hope you written. So this principle of algebra means, okay. So something like this. For example, A over B, C over D. Okay. Then which is equal to XA plus YC. Okay. So I'm multiplying this by X, this by X, this by Y, this by Y. And I can, if I add these two divided by these two, this is also equal to this fraction. Okay. Earlier fraction, which is equal to this one. Okay. It doesn't change anything. That's what it says. Okay. This is algebraic principle. Okay. So you can write this as a note. Okay, write continuously. If P1P plus Q1Q plus R1R, which is equal to 0. So if it is 0, okay, what is this one? It is our denominator, isn't it? Then we know that this is our denominator, okay? Denominator. So if it is so, then we know that the numerator of equation number 2 is also 0. So what they say, if it is this one is equal to 0, then this one also 0. Because we have done the multiply by same element and we have added. So if it is 0, this is also 0. That's what it says. Okay. So write continuously. This gives P1 dx plus Q1 dy plus R1 dz as, so if it is this is 0, okay. So after we after we integrate it, we will get C1, okay, or C, let's say C, okay, which can, it means the 0 we take as a C, okay, which can be integrated to phi xyz, that is equal to C1, okay. So from this, if we integrate, we get pi xyz, which is equal to C1. Then this method may be repeated to get another integral, that is chi xyz, that will be C2. Okay. So this P1, Q1R, if it is 0, then we know the numerator also 0. This gives, which we taken as a C, when we are integrating, we will definitely get, because of this 0, we will get 1 C1 now. Similarly, if you use the, if you do the other repeated one, then we'll have pi xy is equal to C2. Okay. Here, so write down here, this P1 This one we have taken now. P1, Q1, R1 are called multipliers. Multipliers. Okay. Okay. Shall I erase? So when you're doing the example, we can understand more clear. Okay. So you can put note. In special cases, P1, Q1, R1 can be constants too. So we have constants too. We have taken this one as a XYZ and functions now. So sometimes we may need only the constant like 2, 3, 5, some numbers. Okay. It may come as a constants too. Also, if you use that P1P plus Q1Q plus R1R, which is equal to, so this like P1, sorry, this one dx, no? So dy dz P1P plus Q1Q plus R1R, okay? Sometimes you may have only one integral, okay? So sometimes only one integral is, okay, our meeting will be finished. So let me finish also. Is one integral is possible. So we can get the second integral by using type 1, 2 rules, okay? So we can see if it is the situation comes, okay? So in some special cases, maybe constants too, and also sometime one integral only possible. So we can use our earlier techniques to get the second integral, okay? So let's do one question and we can finish our lecture today. Okay, let's do this example. So put this, let's say mz minus n by p, nx minus l by q. So we know this is our p, this is our q, this is our r. Okay, that's not a problem. So we can't solve this one because many z they are y they are in x and z in y and x in r, sorry dz. So it will be a big not possible integral, normal integral of type 1 and type 2. Okay, so there you have to know where to use which questions, which okay. examples and questions. According to the type, you have to choose the way how to solve it. Okay. So here it is possible by the Lagrange's multiplier. So let's see. Okay. So I'll use my. So write down just the questions. The question says mz minus ny of p plus nx minus lz of q, which is equal to ly minus mx. Okay. So let's solve. So therefore the Lagrangian auxiliary it's a capital, okay? It's a one person's name. Lagrangian's auxiliary equations given by what? dy over p, dy over q, dz over the r. So as we know, you have to know this is our p. So write down what is p, what is q, what is r. Okay. And then substitute. Okay. dx over what is our p? mz minus ny. So dy nx minus lz. So dz is equal to ly minus mx. So as you know, all these steps are equal to any method 1, 2, 3. Okay. So when you're writing this point of time, you may find, okay, this is hard to do by type 1 or type 2 or type 3. In this point only, you have to decide which type it is. Okay. So you have to know, okay, this will be hard from type 1 and 2. So let's use the Lagrange multiplier. So what it says, so you have to find capital any, okay? So let's say P1, Q1, R1, according to make the denominator equal to 0. So you have to choose the multiplier. They won't give you. You have to choose is, okay. Give me a second. Okay, you have to choose this according to this denominator, the addition of the denominator of times of whatever you are choosing as a multiplier should equal to 0. Okay, so you know this one, you know this one, you know this one. So you have to find out which make this denominator 0 by choosing this numerator. Okay, so when you're doing so many practices, it will come in handy. Okay, so at first it may seem a little bit harder, but when you're doing many exercises, it will be very easy. So in one point of time, you can find out. Okay, so I will do that one. For example, so I have my capital P is what? Mz minus ny. Okay, q. So according to this only you're gonna decide. Okay, this is nx minus lz. R is what? Ly minus mz. So if you add something times this one, something like this one, something like this one, okay, you have to make it 0. Okay, so see whether what are the commons. So if there are subtraction, no, if you have the same element, so if you subtract, it will be 0, no. So what makes it same? So see here, this is mz, sorry, this is mx, no? So see here, this is mz, this is mx. So if you want to take these two, okay, so x is here in the zr, mz is there. So let me use my idea, okay, my capital P1, I choose x. If I choose x here, if I choose that here, it will go off, no? Am I right? So this will be mz, mxz. This will be mxz. Both will be gone. Okay. So, okay, my R1 also I have choose that. So what make this one? See here, this one. nxy. Here I have nx. So what I need to multiply? So if you want to take this out, xy, no? Okay. So I'm gonna choose, see, very easy. So you can choose this way. So whatever you are choosing, you have to multiply by the numerator also, no? Okay, can you write down the equation? So I have gave you what is my P1, what is my this is how you have to find out. Okay, you have to give some time to take the possible values for this one. Okay, so when you're doing so many practices, it will easy for you. Okay, so I will go to our answer. Okay, so hope you can understand here. So our meeting will be finished within 2 minutes. So let me finish this example and do that. Okay, so see here. So x dx plus y dy and z. You can take some screenshot if you can't write down quickly. Okay, see x dx plus y dy plus z dz. So a denominator also I have multiplied. So see here, this will be, see if you this will be mxz. Okay, this is nxy. So see the common one. So this will be my mxz. This will be my, this will go. This will be nxy. This will be nxy. So minus and plus, it will go. See here, this is lyz. This is also lyz now. So all will be go. So this will be 0. So our actual target is this one now. We have to take the denominator 0. We can keep the numerator whatever it comes. We have to multiply by these terms. Okay. Therefore, we got x dx plus, so if it is 0, you have to know the numerator also 0. X dx plus y dy z dz is equal to 0. Or if you take the integration, it's not okay. So you just integrating, okay, you can, they have multiplied by 2, no problem, okay. So if you integrating x dx integrate by this one by 2, no, this will be 2, this will be 2. If you take 2, what is the answer? My pi xyz, which will be x square. I can take all the 2 out. So that's why they choose 2 already, okay. It's not a problem. So y square plus z square. This is our pi. Okay. Hope you're understanding. Okay, we have only 1 minute, so I'll finish quickly. Okay. So take this screenshot of down part. Sorry. Yeah. No need to take this one. This one only.